Hi, I'm Dr. Kamakshaya. I've been creating a series of demonstrations related to spreadsheet modeling in Excel. In my previous videos, I've explained very basic aspects as how to deal with data inside a spreadsheet. In this video, I'm going to explain about Chi-square test. Okay, the Chi-square test is a non-parametric statistical test which is used for testing the inference or hypothesis related to the cross steps. Okay, we also call them as contingency tables, just like the one I'm showing in my screen. So there are two important aspects in a chi-square test. They're called observed frequencies and expected frequencies, just like this. So we need to sum up the standardized deviation between the observed frequencies and expected frequencies, and the sum of the values, and the resulting sum is known as the chi-square statistic. So in Excel, it is very easy to do. Maybe in theory, it looks like a bit difficult for grasping, but in Excel, it is very easy. So we need to do the whole activity in a few steps. By the way, chi-square test needs categorical data because it is non-parametric. Does not depend on the parameters of the underlying theoretical distribution, just like normal distribution, binomial distribution, something like that. So it is free from all the assumptions of normality. So as such, it depends. It does not. It requires categorical data. So now in my spreadsheet, this is just. I have two data variables. These are actually simulated data using some rand between functions, and my assumption is that I would like to test the dependency in between these two variables. Like I assume that salary depends on age and inter-age levels. Age level differences to salary are statistically significant number of ways. Like it all depends, and you just have to read the theory in order to understand why. If you, after understanding the chi-square statistic chi-square test, you will be knowing, like usually in the bivariate chi-square test, the null hypothesis is that the variables under study are independent. So that's how we define null hypothesis. It's all there online. And alternative hypothesis is that the variables under study depend on each other. So here, salary depends on age does not depend on salary. Okay. Anyway, so but even then we can have a reasonable assumption that. So when I talk about the age, I do state my hypothesis as age level differences to salary are statistically significant. That is my alternative hypothesis. Insignificant or not significant, that is null hypothesis. So when I talk with respect to salary, salary does not depend on age, that is null hypothesis. Salary depends on age, that is alternative hypothesis, something like that. So now since it is continuous numeric data, I need to convert that into discrete categorical data. Okay, for that I'm going to use if statement, if function. This is one of the spreadsheet inbuilt functions in spreadsheets Excel. I am using AND rule for this another function. So because I need a lower limit and upper limit to take a call on the categories. So before I do that categorization, you see my minimum value is 21, maximum value is 90. So I can have 0 to 50, 50 to 100 as two reasonable categories to my age data variable. Okay, so you can just like that to compute the range, and there are different approaches to take a call on how many. You can even have 3 categories, 4 categories, 5 categories, but for the sake of simplicity, I am categorizing my age variable into 2 categories. And if you want me to demonstrate how to do that for more categories, then you can just give a comment so that I can do more. Okay, if and why and is because I have lower limit. And by the way, we have another function if s that is different. Okay, if the cell value is greater than 0, comma, the same cell value is less than or equal to 50, then close the parenthesis. Then I want my spreadsheet to print 0 to 50, else it should be 50 to 100. So that is how I am going to define my value. So I'm just going to fill down rest of the, you just have to go back and check for consistency. Yes, 55 falls between 50 to 100, 65, yes, 50 to 100, and 30, 0 to 50. Sometimes we do few typos in formulas. As a result, it doesn't give consistent values. Now same thing, I want to do it for salary. This time I don't need to salary new, just to distinguish the name from the old name. I am affixing with underscore new. Now choose this, select entire range, then shift right arrow and then control R. That's it. Now go back, and if you use edit, I mean F2 button, it will highlight the formula for you, and you can just check if your formula is considered. Yes, my formula is okay, I don't have any mistakes, and now my values are also inconsistent with the categories. Okay, fine. Now how are we going to, step number 2, how are we going to, we converted the data, that is step number 1. Now in step number 2 we need to convert these two variables into a cross tab. So in Excel, if you press Alt H, you'll go to the home, and then I think it's not H, actually an insert. The very first option, left upper corner, you have pivot table. You need to press V and then enter. Now it is asking you what are the variables you just wanted to include. I don't want all these variables, I just want these two variables, enough for me. And now the context window is asking me, do you want to create this pivot table in new worksheet or existing worksheet? Yes, I want to do it in new worksheet. Now I have only two variables, two of the variables. You just select both of them. Now drag one of the variables in the columns. It doesn't matter like which are, usually I keep lower number of categories in the variable which has low number of categories in columns, and a variable which has a high number of marginally relatively high number of more number of categories in rows. Okay, and now just choose one of the variables into the values and see that it is count, not the sum. Now this is the cross tab, right? We got the cross tab. So our contingency table cross tab is ready. Now step number 3, we need to calculate expected frequencies. That is what is the formula talks about, like in observed frequencies minus expected frequencies to the power of 2 divided by expected frequencies. So it is nothing but standardization of the deviation between observed frequencies and expected frequencies. That is all about theory. Okay, now what I'm going to do, technically what I should do here is, so let me consider this table is observed frequencies, and you can also create a chart here. Most of the time whenever we are doing a Chi-square test, we usually create a chart and observe the values. Usually it should be better a bar chart. You can do many things, but now which one is what? So here age new shows 0 to 50 and 0 to this is age new is 50 to 100. Now if you put the cursor, if you bring the cursor on any one of the bars, here the value will be highlighted to you. You see, if you when I'm placing the cursor on this blue color short bar, it's showing me the value 4, which means this is the cell. This bar belongs to this cell. Now when I'm placing my cursor on the second bar, it shows 7. So what are we comparing here? We are comparing the 0 to 50 category of salary with 0 to 50 category, 0 to 50, 50 to 100, the two of the categories of the age. So these two bars belongs to two of the categories of age, but each one of them belongs to same category of salary. So that is how. So if you listen, it might be a bit confusing, but just start doing it, then everything will fall down into the order. Okay. Now we have the observed frequencies. Now we need to calculate the expected frequencies. How are we going to do that? Now the way to do it is, now for each of these frequencies, observed frequencies, we need to have the expected frequency. That is the rule. Now how am I going to calculate the expected frequency for this observed frequency, which is 4, right? So what I need to do is that is equal to multiply the row total with the corresponding column total and divide it by the grand total. So this is what technically called expected frequency. Okay, so if your cross tab is tiny, it doesn't matter, like you can just do it manually. And then, but if you have marginally large table, then you have a shortcut, so which is actually a formula. Now I'm going to show you that formula. It is called M-mult, okay, matrix multiplication. So what is this M-mult? We are just going to treat the row totals and the column totals as two independent matrices, and now we divide that with the grand total. Okay, now it is not going to, if you press enter, yeah, so in this version of Excel it is creating the whole. Earlier versions we used to execute control shift enter, that is called array the execution of an array function. That is how we execute the array functions. Okay, so fine. So now we got an array of values which are expected frequencies. Now what? We just have to use one single formula, that is chi-square test. Where is it? It is here. Now this chi-square test is going to, see, there is actual range, which means observed values, and then there is expected range, that is expected values. Okay, and you just have to, I think something is going wrong here, don't know why. Okay, fine. Now still it is not okay, but let me see. So maybe this, I don't know. Okay, now this is the p-value for the chi-square test. So it doesn't give chi-square statistic, it gives you the p-value. Now in order to calculate, this is p-value for this is a test. We determine the, we'll take the inference, or we take the decision by looking at the p-value, not at the olden days we used to consider chi-square value to take the decision, but nowadays we are so smart, we'll use p-value. Now what is the p-value? It is 0.89. so at 5% significance level, this value is very high, right? So 0.89 is greater than 0.05. So which means we fail to reject null hypothesis. What is our null hypothesis? Our null hypothesis is that age and salary, both of them are independent. They does not depend on each other. So otherwise, salary does not depend on age. In other words, salary does not depend on age, or age level differences to salary are insignificant. So that's how we take. Now, for one final step, if you want to know the chi-square value, you have a function called chi-square inverse. Okay, let's see what is there. Yeah, the first argument is probability, and next argument is degrees of freedom. Now, how are we going to calculate degrees of freedom? Now you see, we have two rows and two columns. So usually the degrees of DOF is calculated as R minus 1 multiplied C minus 1. R stands for number of rows, C stands for number of columns. So 2 minus 1 multiplied 2 minus 1, it is 1 into 1 is 1. So here, so I'm going to put 1 degrees of freedom for this cross tab. Now the chi-square statistic is 2.580. Now you can compare this with the critical value of, at 5% significance level, what is the standard value of chi-square? Standard chi-square value at 5% significance level. Then compare this value with that value, and then can take the decision whether we are really going to reject the null hypothesis. But as far as the p-value is concerned, we fail to reject the null hypothesis, and our decision is that salary does not depend on age, or both the variables are independent of each other. So this is how we take the decisions, by performing chi-square test in Excel application, spreadsheet application. Okay, thanks for watching this video. Stay tuned for the new content.